Next up, we've got one from the United States of America, from Colorado. Hi to all my viewers in Colorado. This is from IONA Tech. Thank you very much. And I know what this is, and it could be really interesting. It's not something we've had on the mailbag before, so let's check it out. It's a really interesting bit of kit, so I'm curious to see what actually happens here. Oh, they sent me a shirt. There you go, I've got on my IONA Tech shirt, and the static symbol might give you a bit of a spoiler of what's going on here. Here we go. It's the StatIQ Band. The StatIQ Band by IONA Tech wirelessly measures human body voltage and provides audible alarms that identify ESD concerns, enabling newfound mobility around the workplace. Made in Colorado in the United States of America. Yes, the blurb was on the back. I didn't memorize that. So, yeah, this is a static, it's not an anti-static wristband. It's a wristband that monitors, well, oh, look at that. Look at that. Oh, we've even got, is that a certificate of calibration? Thank you very much. Oh, that's sexy. Wow. This is a really interesting bit of kit. This is really sexy. Let's see if it works. So here it is. Here's our cal sheet. It just uses a high voltage power supply here, so they calibrate it at a given distance, as you've seen me do in my static video. Now, look at this. Look at the gold plating on there. Oh, wow. Doesn't that look sexy? It's really designed as like an armband thing, and they show you that up here. It's not really designed to go on the wrist because it is, like, it is quite huge. I mean, check that out. So designed to put up on the arm like that, and it basically designed to tell you if your body's charged up to, you know, some sort of threshold. It looks like we've got a shoe phone app here. I assume it like beeps internally or whatever. And, oh, there we go. Oh, look, it's spinning. It's spinning. Yeah, check it out. They've got like a little spinny wheel in there. So watch it. There we go. It spins up and you can't hear that. It's silent, but they're using that to rotate. That's interesting. They're using that as some sort of chopper measurement system or something. Anyway, it looks like we've got an alloy back on here. It's very professional. I don't know the cost of this. I'll put it up here, but I'm sure it's not particularly cheap. This is not something that a hobbyist would buy, right? It's designed for like a serious ESD environment in, you know, like really high-tech, expensive state-of-the-art labs that have, you know, really expensive equipment that you're working on. So yeah, anyway, it's interesting. So USB-C, it's obviously got a rechargeable battery in there, and so here you go. I've got their ESD shirt on, and apparently you've got to strap it to the outside. So it's obviously designed for like ESD lab coats, obviously. But I'm just going to wear the shirt here. I might try the lab coat later. In fact, I've got a full clean room ESD bunny suit. But yeah, it's spinning. Let's download the app and see if we can actually get any measurements. Got the shoe phone here, installed the app, available for the Androids, and it asks for the location, but I think it might only need this because this is a Bluetooth thing. Even the 121 GW meter app does this because it's just a requirement of the Bluetooth driver. It's really annoying. Anyway, only while using the app Enable G. Why does it need No, this is getting silly now. GPS location, bugger off. Can I cancel it? Available devices. Please enable GPS location. What? What? I can imagine that being a security concern for companies, maybe? I don't know, but how am I supposed to go? I'm inside a lab. Anyway, there it is. I think it's just for driver reasons, I suspect. Anyway, StatBand, there it is. It actually detected it. No worries. I'm connected to it now. And look, it's got the voltage. I'm dragging, oh, my feet. There you go. I'm dragging my feet on the carpet. I got my rubber-soled shoes on. Minus 1500 volts. There you go. That's interesting. And if I go back to the ESD mat, vroom, look at that. Bobby Dad, that's working. That is working. Wow. I like that. Don't know what those red dots are. Oh, ESD event. Right. Is that because is that a rate of change thing? That doesn't seem like a level. It seems like a rate of change. And if I keep my hand on the mat and I rub the feet like this, you can see that it's really attenuating that. Yeah, and eventually drains back out. That is working. Nice. Anyway, it shows the battery up here. And buzzer threshold. Okay, so it didn't buzz on me. Alarm's audible. There you go. Yep, there you go. It's beeping. Ha, this is great. Nice. Wow, and you can get with slower intervals, 1 minute and 5 minutes. This is very impressive. Oh, now I can actually hear it. I can just briefly hear the little motor in it. Now it's gone. Don't know what happened there. Maybe it's sped up. Yeah, there we go. I just heard it again. Maybe it's like it's spinning up and down or something like that. Anyway, there are LEDs on there. Oh, green and blue. Blue is obviously I believe the connection, because I haven't even RTFM'd yet, right? And like, anyway, it's doing the business. You can set the alarm volume, but that's basically it. You don't want any more complexity than that. I mean, the more complexity you have, the more you're going to come a gutser. But that's really quite nice. And you can have multiple devices, so I don't know how many maximum, but, you know, multiple people in the lab or whatnot. Well, yep, there we go. Beep, beep, beep. And there also seems to be a direct correlation between the impedance of my earth-in and, like, if I'm just standing here on the floor like this, okay, and then if I touch the mat, which is earth some way away, then obviously we can, you know, because it's got the resistive spread across the mat, you know, it still keeps it low, but it's not zero. And then I grab my ESD wrist strap, and I've still got, and that's going directly to mains earth via a couple of meg. And if I go directly to mains earth by touching my oscilloscope ground, I'm really not doing anything there. So this seems legit. If I've got like a loosey-goosey earth strap, it's a little bit loose there, then, you know, there's a bit more generation, but if I hold that B and C, boom, wow. Well, I've got the full clean room bunny suit, including the including the boots, and it's just, it's going off the scale. It doesn't like it at all. So maybe I've got to stop it and recalibrate and turn it on. Maybe it recalibrates itself. I don't know what the deal is. I should RTFM, really. No, you can see it's constantly high there. Even if I ground myself, like I got my ESD strap just like I was before, but for some reason on this full clean room bunny suit, something's out of whack. It's the bunny suit, because you remember this thing, I did actually take it through a complete mud obstacle event. So I'd say this bunny suit is, yeah, kind of ruined. Little thing I didn't anticipate, water pooling in the suit like that. Little bit of a track for young players, that one, for those who want to do this.
Thank you.
Now I've got a proper working ESD on, and but once again I've got it back on and it seems to be operational again. So I'll swipe my feet like that and boom, ground myself on the ESD mat and we're back to normal. So yeah, so that's actually probably not a bad test to show you that this thing actually picked up a dodgy ESD a bunny suit, because this thing, they said you have to have it on a proper working ESD you know, shirt or lab coat or something. Yeah, because I think that thing got destroyed when I took it through a mud obstacle event, and even then it was completely used and worn out. So it was even dodgy, obsolete back then before I even took it through the obstacle event. But anyway, this is working. But I know what you're thinking, Dave, is this thing BS or is it actually legit? Well, I've got my Surface DC Voltmeter here from Alpha Labs, which I've calibrated the distance at 1 inch here to a metal plate. And, well, we can basically ground this plate. So I've got it grounded at the moment. Okay, so we can reset this. Let's disconnect the ground and we reset it. Okay. So there you go, it's a 5 volts, like, you know, there's nothing doing there, okay? And let's have a look here at this, and let's see. I'm going to build up, build up, build up, and we're going to have to get a stable voltage, but hopefully, okay, it's at now 600 volts. Let's call that 500. Let's wait until it gets to 400, then I'll charge this plate to 400 volts. Here we go, boom. And 350, it's actually dropped a bit. It's pretty close. It's a 330. Yeah, that's, you know, give or take, like, you know, 10 or 20 volts or something like that. It's pretty close, but that's what you expect. You know, you don't expect it to be accurate to a volt or whatever. Anyway, I can build that up to, basically, I don't have to touch it. It's 5, just under 400, 490 volts. Yep, yep. And this plate is going to be equal to, that should be 640. That's pretty darn close. And hopefully you're seeing that. That's pretty impressively close. It did peak over a kilovolt there. You saw it. Reset. Remove the ground. And we can try it again. 360. That's pretty close. Yeah, this is pretty close. This is great. Let's see if I can get bigger. Sorry, I should wear better underwear to generate more. But yeah, 1.1 kilovolts. Yep, yep, yep. Just on one. Yep, that is bang on. Wow, I'm impressed. And you can see that plate was isolated from the bench there. So that's a pretty accurate validation test that this thing is not BS. This actually works. So I'm sure there's some, you know, patented technology behind this. This is all the company does. It's a startup who specifically does this sort of thing. One of the founders is a former professor from the University of Western Sydney here. And they also provide you with this nice little grounding calibration plate. And you just stick this in here and it should beep. And is it going to beep? Yep, there it is. And yeah, it's referenced back to 0. So you might be wondering, how the heck does this work? I mean, it seems like magic, right? But it's not magic. It's just clever. What it is it's basically a DC surface voltmeter like this, which uses a plate like this, and of course it's calibrated. It tells you, you know, it's calibrated 1 kilovolt at 1 inch, right? So that's why I calibrated at 1 inch from the surface of the plate. And these surface DC voltmeters, you can buy these. They're as common as mud, right? And there's proven science. Once you charge up a plate, then the electric field at a distance, you can actually measure that. So how this works is, you can see it's got the conductive bands on here. So that's actually measuring basically the surface of your body through, of course, that's why you've got to have a conductive ESD coat. And that also explains why that dodgy ESD coat, which obviously is crap now, it didn't work, because it was basically an insulator, and you've got an insulator between there and the spinning detection plate on the top, or the spinning detection mechanism on the top, because it's not just that one plate. So that just upset all of the readings. So that's why it didn't work. But when I put on a real working ESD coat, or I used the shirt that they provided, a proper conductive coat, then it's actually measuring the surface of my body. So what they've got here is basically a similar thing. They've got a plate which is separated by a distance to basically the grounded, your grounded body here. So it's like, I mean, you could kind of, sort of get the same thing. If I, you know, strap this thing with a spacer to my body, I could actually, like, go around and I could, you know, basically measure my body as well. But this is a bit cleverer, because it's got a, hence why it's got a spin, I believe, is that it's going to be, like, periodically grounding the thing. Otherwise, the charge would build up and, you know, it'd just it'd run away, and, you know, you wouldn't get any accurate readings. But this samples at 1200 times a second, and they've got the spinny plate. So you can obviously see down in there that they've actually got, well, there's effectively 3. There's the spinning plate, and then you can see that there's an inner shape on the PCB there, and then there's an outer one as well around there. And is this ground ring connected to the plate? I'm not exactly, you know, sure of the exact implementation of it, but it's basically working as basically an auto-zeroing or an auto-correcting, I guess you could call it, surface DC voltmeter, because it's just designed to be physically separated from your body. So, of course, it's only going to work if you have that conductive surface, of course. So, yeah. It's brilliant. They've been able to implement this thing because obviously, you know, the spinning plate is obviously a part of the auto correction, you know, technology inside this thing that allows you to get a constant update. And it works. Wow. It is like magic, but there's basically pure science behind this. And they explain all the physics behind it in the user manual, but I'll insert a clip here from one of the designers and founders of this thing. Briefly explaining down the work. I'll link the full video in down below.
How does IONA's device actually measure the human body voltage? All conductive objects have some capacitance. For simple shapes like a sphere, we can calculate it. For more complex shapes like a human body, it's a little harder, but they all have a basic intrinsic capacitance. And when that capacitor acquires some charge, then the voltage of the object goes up according to a well-known equation, V equals charge over capacitance. We can't measure that voltage directly. In order to do so, we'd have to have some kind of wires to a voltmeter. What we can measure, however, is the electric field produced from the skin of the body. And IONA has developed the world's smallest and most accurate electric field sensor, what we call an electric field mill, that measures that electric field. It's well known in physics that the electric field is proportional to the charge density, the amount of charge that's on the skin of the body below that electric field sensor. From the charge density, we can make an estimate at the amount of charge on the whole body. We can just multiply or extrapolate that charge density to the charge on the entire body. Once we know that, we have the charge, we have the capacitance, and we can calculate the voltage. So our sequence of measurement goes from electric field to charge density to total charge to voltage. And that is how IONA is able to make a body voltage measurement without any wires.
There are a few scenarios in which the relationship between E field and body voltage breaks down. For example, if I'm naturally charged and I stand next to a grounded workstation or wall, the charge distribution on my body will be asymmetric and the voltage measurement from the static band will be slightly higher or lower than my actual voltage. However, the polarity is always correct and zero charge means zero voltage. Second, if I stand next to a charged insulator, such as this acrylic banner, the charged panel will induce a charge in my body even if I am grounded, and the static band will detect this. Just remember that a non-zero voltage measurement from the static band always indicates the presence of charge on the user, which should be considered an ESD concern.
But yeah, it's basic physics and a clever implementation of an auto zero-in, auto correction system, so it can sample really fast. And you know, if it gets out of whack, you can actually zero and recalibrate the thing. And it's neat. Anyway, that is not BS at all. That actually works. So very impressive bit of, interesting bit of very industry-specific kit. Once again, you know, for a very niche market, I'm sure they're not going to sell millions of these things, but the people that need this are going to think that this is the absolute duck's guts. So it's very impressive. So thank you very much, IONA Tech, for sending that into the mailbag, and I decided to spin this out as a separate video. It's so interesting. So yeah, that is not BS, unlike those anti-static wireless wristbands, which I'll put the video up here if you haven't seen it. That's just a joke. But hey, LCSC, their factory was using those wireless wristbands until I pointed it out to them and showed them my video, and they went, oh, oops. Sorry, we'll use real ESD bands in the future. Thank you very much. Anyway, I'll link that video in if you haven't seen it. So anyway, that gets a big thumbs up. That is really a fantastic bit of kit. So there you go. That's the StatIQ or StatIQ, I'm sure it's how it's pronounced, band from IONA Tech. And that is really amazing. Now, unfortunately, they don't have a price on the website. Like I said, it's really only for like really professional businesses who take ESD incredibly seriously, and of course with the multiple users, and this can, I think, report back to the cloud, and it can cloud storage and stuff. So the QA department is just going to wet their pants over getting this sort of data from their users walking around in the lab when, you know, you're like $100 million space probe that's going to Pluto or whatever. You don't want to blow the thing, and you can actually detect whether or not and continuously monitor people walking around. And I think it's got a 16-hour battery life in it, so you charge it up in the morning and it's going to do the entire day's business. So that is real super clever. So yeah, don't ask the price. Well, you can go and ask them the price if you're serious, but I'm sure it costs a very pretty penny. But wow, that is a remarkable bit of tech, and it does actually work. Fantastic. So hats off to getting a physical, practical implementation of this. I can't imagine this would have been an easy design to do. And just like my Surface DC Voltmeter has a grounding point on it, so does this. There you go. So you can actually just connect that in for various scenarios where you can require that. But you can basically use this as a Surface DC Voltmeter. It's going to work exactly the same as this, essentially, but it's designed to go onto your body and then continuously work all day and auto correct itself to ensure, you know, reasonable calibration. Once again, you don't have to be accurate to a volt. You know, a few tens of volts is just fine. It's designed, and it can measure those ESD events that actually are fast pulse down, and they're the really troublesome one. So you can just imagine somebody sitting in the QA department, the klaxon sound because somebody ESD impulsed in the new NASA, you know, satellite construction room or whatever, and they race down there and we know who it was because we've got your ID from this thing, and it does remote firmware updates as well through the app. Like, oh wow, unbelievable. Yeah, this thing's not going to be cheap. Anyway, as always, thoughts and comments on that down below and over on the EEVblog forum. Catch you next time.